weeks or maybe a month or two, but then winter will be coming along, and it's powered by solar panels, and once the sun is gone, there will be no chance for it. As well, there will be carbon dioxide and water ice that will be layering over this area. So it is not likely that the Phoenix lander would be able to last through the winter.
Okay, understood. Yeah. Now, it wouldn't last through the winter because, I mean, it wouldn't have any power, correct?
That's part of it, but also it's likely that some of the electronics could become damaged. In that very cold temperatures.
Oh, very cold. So it's not like it could be covered up with ice and then in the spring it thaw out and it'd start working again.
Probably. Not likely. That would be quite the engineering feat if they could pull that off.
Yeah, no kidding. That's right. Well, I got a little image of the little scoop that's out there digging in the Martian landscape, and I had heard that it was supposed to be able to dig down like a couple of feet, right? I mean, if it was
about that much.
About
yes.
that much, yeah. Okay.
But that will depend on where the ice is and how hard it is. It doesn't actually have much capability in doing any more than chipping away at the ice.
Because what we see here on the picture is that's it for the scoop. It doesn't have any kind of like little grinding tool or anything like that. It can just kind of like do more substantial digs into the Martian soil, right?
Right.
All right.
So I see a question here from Brainbox asking about how many people are involved in operations of Phoenix. And it's interesting that there are many tens of people, actually, scientists and engineers and others working on this. They are following a very weird sleeping schedule. They're actually following the Martian 24 hours.
The Martian day is what they're following.
Yes, exactly. So they are trying to follow along with Mars time. In fact, they are awake when Phoenix is asleep, and they are asleep when Phoenix is awake. So poring over the data, that night after the information is received. High-rise, kind of the extent of our involvement was viewing this descent and also looking for the lander on the surface. And we did take 3 pictures of the lander on the surface, and we were able, with our very high resolution, to pull out and you can actually see the rover, and you can see those images on our website as well.
I'm trying to, on your High-Rise website, right?
Mm-hmm.
Yeah, I'm going to try and get some of those images here for the Ustream chat. Right now, you're just seeing me typing around on the internet while Richard is speaking here. But that's pretty exciting. I didn't, I had known you were involved somehow with the Jet Propulsion Laboratory or, with the Mars mission, but I wasn't sure. That's very interesting. Let me just say that.
I see another question here. So High-Rise is actually a camera on board an orbiter, and that's the Mars Reconnaissance Orbiter that arrived in 2006. And so we have a nominal 2-year mission that will be ending in November, but we have been approved for an extended mission. We haven't heard any details about the funding yet, but I think I still have a job, so we'll find out for sure later.
Yeah, that is kind of a question nowadays, is funding for a lot of these NASA programs. I mean, there have been cuts recently. Or budget constraints, let's say.
Yeah, there's a couple things going on. In addition to the budget constraints, there's also this almost movement within the planetary science community to begin to stop focusing on Mars and start to emphasize or pay more attention to the outer solar system. The outer solar system has become a much more exciting place.
Really?
With a few key discoveries by the Cassini mission, which is currently at Saturn.
Oh, like on Enceladus, the planet there, that they think that there could maybe be some signs of life there because there may be liquid water.
Yes,
on one of Saturn's moons, right?
Right, and it turns out, this decades-old view of the outer solar system as a cold and dead place is absolutely not true. There's perhaps as much geological activity going on in some locations as there is on Earth. For example, Titan, a moon of Saturn, appears very, very Earth-like in its rivers, its potential volcano.
With the caveat that the rivers are liquid hydrocarbons on
Right,
Titan.
exactly.
Because it's much colder, correct?
Right.
It's like minus 200 Celsius or something like that, or minus 150. I don't know, in that range.
Yeah, even colder than that, but around about that range, yes.
But it looks exactly like Earth, except instead of the geologic properties operating on water, it operates on liquid hydrocarbons. It seems like there are lakes. The clouds rain methane. There's ice, which is liquid hydrocarbon ice. So it looks extremely similar to Earth, except it's all hydrocarbon.
Right, and so here on the Earth, the bedrock, most of our rocks are silicates. On Titan, the rocks are solid ice. Ice that is a mineral and part of the rocks. And all of this overlays what appears to be a liquid water and ammonian ocean. And so there's still evidence being gathered to support this hypothesis, but it appears that this solid ice crust overlays a liquid ocean. So it's a very, very fascinating place, and it seems every time they turn around, they discover some other fascinating new place. Enceladus was interesting because it's so tiny.
Yeah.
It's just a mere 300 kilometers across.
Yeah, smaller than the Earth's moon.
Oh, much smaller. Yes,
yeah.
it's right at that threshold where objects, any